Networking fundamentals. In this nugget, we're going to talk about some basic networking concepts. We'll talk about IP addresses, the various protocols, subnets, and net masks. If all of these terms aren't familiar to you, that's okay, because we're going to cover each one from the ground up. Then we'll look at some applications and some Linux commands that help you use the network for everyday tasks, and also help you troubleshoot when things aren't quite working the way that you want. All right, well, let's get down to it. Well, let's start a discussion of networking fundamentals by talking about IP addresses. An IP address is how we distinguish all the different computers on the internet. That's sort of the unique address for all the different computers that are on the internet. Now, an IP address is composed of 4 numbers, and these 4 numbers are sometimes called octets. And the reason each of these numbers is called an octet is because each one is composed of 8 binary digits. Now, an 8-bit binary number can range from 00000000, which is equal to the number 0, up to 11111111, which is equal to the number 255. So each number that that makes up an IP address can be in between 0 and 255 inclusively. Okay, so that's what an IP address is. It's composed of these 4 octets. I've written out the binary representation of this particular IP address here for you. We're going to need to mess with the binary representations in a few minutes when we talk about net masks. If you are not comfortable with binary arithmetic, just plug each of these numbers individually into a calculator and hit the binary button. So if you type in 192 and hit the binary button, then this is the number that will come out. If you type in 168 and hit the binary button, this will come out, and so on. Now, there are different network classes on the internet. And these network classes are distinguished by their IP addresses. So Class A networks have IP addresses that range between 1 dot something 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 up to 126 dot something something something. If you have a Class A network, your network is defined by the first number, the first octet of the network. So if you own a Class A network, if you've been given one by Internet, which is in charge of doing this, like if you're like the US government or something, then your IP addresses might start with like the number 17. Okay, and then you have all of the IP addresses, 17.000, 17.001, 17.002, da 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 da, all those addresses. So there's only 126 different Class A networks. All right, but each one of those Class A networks has like 16 million and some hosts inside of that Class A network. Okay, then there's Class B networks. Now, Class B networks fall in the range 128 something 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 up to 191 something something something. But when you own a Class B network, your network is defined by the first 2 octets of the IP address. So if I owned a Class B network, or my company did or something, it could be something like 130.140, and then we get all the addresses that start with 130.140. So we get 130.140.0.0, 130.140.0.1, la-di-da-di-da. Okay, so there's a lot more Class B networks. There's like 65,000 and some Class B networks, and each one of those, or I'm sorry, there's 16,000 of those Class B networks, and each one of those networks can have 65,000 hosts inside of it. Okay, then there's Class C networks. Now, Class C networks fall in the range 192 something 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 up to 223 something something something. And if you own a Class C network, your network is defined by the first 3 octets of the internet address. So if I owned a Class C network, that would be something like, 200.100.10. And then I would own 200.110.0, 200.110.1, and so on. Okay, so Class C networks are even more numerous. All right, there are 2 million and some Class C networks, and each Class C network can only have 254 hosts inside of it. Okay, now Class D and E networks, they're not really common on the internet. E is really for experimental reasons, and D networks are reserved for something else like multicasting, which we're not going to talk about. But these are all of the different network classes that exist on the internet. All right. In each of those classes, and A, B, and C in particular is the only ones that we're going to talk about, there are reserved addresses that nobody gets. So for Class A networks, it's all the things that start with 10. So 10,000 up to 10, 255, 255, 255, everything in that range cannot be owned by anyone. They're reserved for special reasons. Same in the Class B networks. We go from 172.16 block 00 up to 172.31, 255, 255. And for Class C networks, it's everything that starts with 192, 168. Okay, so these addresses are reserved, and while you might see those addresses, they're not really like internet-wide addresses. Routers out there on the internet won't map to these addresses. They're reserved for local purposes. Well, now let's talk about subnets, and we're going to look at this picture that I pulled off the internet from johnscloset.net. Okay, this is a really nice picture and it describes what's going on. I'm going to supplement the text and stuff in this picture with another slide that will page back and forth in between. So what a subnet is it enables a network administrator to further divide the host part of the address into two or more what we call subnets. All right, so let's look at the big picture here. Okay, this line here is representing the backbone of the internet. All right, so everything that goes over the internet travels over this line. All right, now in theory, we could have every single computer in the world hooked up to the internet directly, and then all traffic between computers would go over this line. Okay, that's in theory. But in practice, we could never do that, right? Because if every single email that I exchange with the person sitting at the desk like 20 feet away from me went over the internet, this would get really bogged down, okay? And the bandwidth that this wire would have to accommodate that sort of traffic would have to be huge. Okay, where, so what we like to do here is we would like to break the internet down into these subnets, into this hierarchy like this picture shows. So if I'm sitting here at this computer and I'm sending email to the guy sitting over here, well, it just goes locally over our network. All right, so there's lots of reasons that we want to have subnets. One is this isolation of network traffic. I don't want every single message that, is going to this guy 2 computers away from me to go out over the main internet. That's one reason. There's also security reasons, right? If we're sharing some, private email for our company, it's really hard for that to be stolen if it's traveling over wires that are, in our building and so on. Nobody could be like packet sniffing some router or something if it's physically located in our building. Okay, whereas if it's going out over the internet, who knows what's happening to that. All right, so, and it also allows for simpler administration of the networks. All right, so that's what subnets are. It's like this hierarchy, so we can have local networks within our organization that, these computers are not directly connected to the backbone of the internet, but they're connected there via these routers. Okay, so however, something has to be connected directly to the internet if you're going to have access to the internet, and that's done through this router in this diagram. Now this router has this IP address, 205.158.3.1. All right, and the net mask for this router is 255.255.255.0. What is this net mask? Well, let me explain it this way. Every message that's going out here on the internet has a destination address in it. All right, and those destination addresses decide, where it should go on the internet. Okay, maybe it's going directly to this computer down here, like 205.158.3.18. Well, how is this router supposed to know to take that message and then funnel it through its local internet so that it gets to this computer? Well, the way that it does that is it applies the net mask to the destination address of the message that's passing by. And if the net mask applied to that message is the same as the net mask applied to my IP address as the router's IP address, then the router will accept the message and pass it on to its local internet. Okay, so what do I mean here by applying a net mask to the message or applying the net mask to this particular router? Okay, well, let's go over to this other diagram here. The address of the router is 205.158.3.1, and that's that number written out in binary. Okay, the net mask is 255.255.255.0, and that's that number written out in binary. Now, when I say apply the net mask to the IP address, what I'm doing is I'm actually applying what's called a bitwise AND operation, A-N-D. I'm not adding, I'm ANDing them. And can also be thought of as a bitwise multiply. So forget carrying and stuff like that, but just multiply the bits directly. So 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, and so on. Okay, so you can see here, if the mask is ones, then it's just going to sort of pass through the numbers that are in the address up here. Okay, so a bitwise AND is something real that a computer can do really, really quickly. Okay, and so that's why we use the bitwise AND operation to do this. Okay, so what I'm saying here is the result of applying this net mask to this IP address is what I'm writing out right now. Okay, 6, 7, 8, and then the final ones though are all zeros. Okay, and that's because the mask is all zeros. So 0 times anything is 0, and so no matter what is written up here, it's going to wind up being a 0. Okay, so what is this answer here? Well, the answer here is 205, 158, 3, and then a big fat 0. Okay, so what I'm saying is that when I apply the net mask to this IP address, I get 205.158.3.0. So any message that's floating by out there on the internet, I apply this mask to, and if it matches this, then I will accept the message and pass it on to my local subnet. All right, well, what's going to match this? Well, to match this, it's got to start with 205.158.3, because if it didn't, then, if it started with 205.158.4, then the result of applying this net mask to it would be 205.158.4, and it will not match this answer here. But every single address out there that starts with 205.158.3 will match this address, and so all of those messages will be accepted. And if we go back to our little picture here, you can see what this paragraph says. It says this router has a mask of this, so it accepts traffic for any address starting with 205.158.3 blah. Okay, so that's what this router does. Once it gets that message and it says, yes, I want that message and I want to pass it on to my local subnet, then it gets that message and it passes it on to its local subnet, but then we have more routers involved here. These routers also have IP addresses, and they also have net masks. And so we apply the same game again. Okay, this time the IP address of this router is 205.158.3.17, and the net mask is 255.255.255.240. Okay, in binary, there it is. All right, so now the net mask you can see is all ones, and then 4 more ones, and then 4 zeros. So this net mask, what it was saying was basically ignore the last octet of the address, the destination address. And so if the first 3 octets match, then we'll pass it on. That's what it says in plain English. Okay, that's what this net mask says. It says look at the first 3 numbers in the destination address. If they match 205.158.3, send it on. This one's a little bit harder to say in plain English because it's part of, it's definitely the whole first 3 numbers, so it's got to be 205.158.3. But if the first 4 bits of this are also the same, so what it's saying is ignore the last 4 bits of the destination address. Okay, and that's what we're looking for. And if you, in plain English, what that amounts to is the addresses 205.158.3, and then 16, 17, 18, 19, up to 31. Okay, so anything with those addresses will be accepted by this router and then passed on to its local subnet. Now, a couple things that we've left out of this whole discussion is there's certain addresses within each subnet that are also reserved for special purposes. And namely, an important one is the broadcast address. And you can see here that 205.158.3.31 is a broadcast to all machines in the subnet. So we say that this router accepts traffic for these addresses between 205.158.3.16 and 205.158.3.31, but 31 actually means that the message should be broadcast to all the machines in the subnet. So that's just a special case, and so no machine within the subnet could have that address that ends in the 31. Well, now that we understand a little bit about addresses and how messages are transmitted across the internet and how routers and net masks help determine where messages should go on the internet. Now let's talk about the messages being sent at a sort of a lower level here, and we're going to talk about the TCP/IP suite of protocols. Now you'll hear this acronym TCP/IP thrown around, and TCP and IP are both protocols in their own right. But a lot of times when people talk about TCP/IP, they're talking about a whole suite of protocols, and I've got those all listed out here. So let's talk about these one by one. IP is the Internet Protocol, and IP is responsible for delivering packets. Okay, so when we're talking about stuff being sent across the internet, well, at the internet layer of the whole system, IP is what's delivering the packets from one system to another. Now, these packets could be delivered out of order, all jumbled up, things like that. Maybe the message you're trying to send is big and it can't all fit into one packet, so then it's broken up into multiple packets, and then IP sends these multiple packets. But IP puts on each of those packets a header, and the header says where the packet's going, where it came from, and the order that the packet should be reassembled in so that the original message is preserved. Okay, and so, but IP, the Internet Protocol, is only really responsible for delivering the packets, and it doesn't worry about the order of the packets and that sort of thing. Now, ARP is an address resolution protocol, and this is only used on the local network. So once you get down to the local level, so once you're in your sort of subnet or your network for your local network, then the address resolution protocol will kick in and deliver messages to the actual correct machine in the network. ICMP is the Internet Control Message Protocol. This is used for reporting errors. Okay, and a few utilities that we're going to look at when we go out to the Linux screen. One of those utilities is ping, and ping uses ICMP to do its work, and we'll see what ping is in a few minutes when we go out to the Linux screen. And then there's TCP. So TCP is a transmission control protocol. TCP ensures delivery. Okay, so this is what we call a connection-based protocol. There's some sort of handshaking going on. So if I want to deliver to machine X responds to me and says, yes, I will accept your transmissions, go ahead. And then when I send stuff, machine X verifies that, yes, it got it and everything was received correctly. If something's missing, then machine X would respond back and say, I'm missing packet 42, and then it would go back, I would send packet 42 again, and so on. So this is ensuring delivery of items. So this is good for things like emails or web pages and things like that. Need to have some sort of TCP in some aspect of the system. Okay, so TCP can work together with IP at sort of different layers of the networking hierarchy. All right, so IP could deliver the packets across the actual internet, and then TCP can sort of be layered on top of that and look at the packets, reassemble it, make requests again for new packets if something's missing. Then IP will send those new packets over the lower levels of the internet, and then TCP will sort of receive them and put them all back together. Okay, so these are used sort of in combination with each other. And then there's UDP, which is the user datagram protocol. Now this protocol is what we call a connectionless protocol. Okay, and a connectionless protocol means that it's very streamlined. There isn't this handshaking that needs to go on. I'm just going to start sending you data, and you're going to be receiving the data, and you're going to put it all together as you get it. But you might get some glitches, like it's not guaranteed that everything's going to get to you, but it's very streamlined and it's very fast, and it's very low overhead. So this is good for like streaming video or something like that, right? If you're doing some live broadcast or some streaming broadcast over the internet, then UDP is what's being used for that streaming audio or video, because we're sending the stuff. It's very quick to send it. There's no overhead. I don't have to assemble these packets and put headers on them and things like that. I just get to send all the data. You get to receive it. And if every once in a while there's a little glitch, well, you live with that, right? That's the that's the negative side to this, to the low overhead aspect of UDP. Well, both TCP and UDP use ports on your computer. So when the packets come into your computer, they come in on what's called a specific port. Think of it like a mailbox, okay, for an apartment building. You know, the mailman has all this different mail, and so he puts the mail in the various mailboxes according to how it's addressed on the envelope. All right, and that's similar to the way that ports work in Linux, is that certain packets are going to come in. They might be packets for an FTP transfer or a DNS transfer, an HTTP transfer, things like that. And those that information is coming in on different ports on the computer. Okay, so you can see, you know, this is a page from redhat.com, but this applies to every version of Linux. FTP is a port 21, and then when you go to actually send data across FTP, that's done on port 20. SSH, which is a secure shell, that's done on port 22. Telnet's done on port 23, and so on. So you can see as we go down this list here, all the different services and what ports they use, and some of the more important ones, you know, we just talked about FTP and Telnet. Port 80 is the one that's used for HTTP traffic. 79 is Finger. We're going to talk about Finger in a minute. You don't necessarily even know what all these different services are yet, and that's what we're going to do for the remainder of this nugget. We're going to talk about FTP, and I'll show you how to use it. I'll show you how to use some other utilities for looking at your network. All right, well, let's talk about some of these applications, these network applications that are out there for you to use. One of the more common and useful applications that you should know about is the FTP program. Now, there's various forms of the FTP program, like VFTP and all these different variants. On this particular computer, just the regular old FTP is installed. If you type FTP, you can see you get an FTP prompt. And then what you can do is you can open up a connection to a website. Now, a lot of times, the site that you're going to connect to will start like ftp.fasano.net, for instance. For my particular fasano.net domain, www, that computer has FTP ability built into it as well as HTTP ability. So I'll hit enter there, and we'll open up a connection to fasano.net. Now, once this connection's open, the first thing it says is you have to log in. Okay. Now, logging into this particular computer, sometimes when you log into an FTP service, you can log in what's called anonymously. So you would actually type the word anonymous there, and then when you hit enter, when the password prompt comes up, it would typically say anonymous access is allowed. Type in your email address for for your password, just so they have some sort of record. Although it's not required that there's no check being done there to make sure that you typed in your valid email address. On this particular example, I need to actually type in a username to access this particular computer. You can see that it's defaulted to Perry because Perry is my username on the Nugget SUSE machine. All right. However, on this particular machine, it's FasanoNet is my username, and then it says username okay, need a password. I type in the password, and now it says I'm logged on. Okay, so now I am on my personal website, fasano.net. All right, and I'm back to the FTP prompt. Well, there's all sorts of commands that you can use at the FTP prompt, and you can see those by typing help. And if I scroll back here a little bit, you'll see all the different commands that are there, and you can look up what each of these things does. A lot of them I never use. The most common ones to use are things like get. Okay, that would allow you to get a file from the FTP server, okay, fasano.net in this case, and bring it to my local machine, Nugget SUSE in this case. Okay. The other thing that you can do with FTP is a put. All right. So if I want to put a file from my local machine out to fasano.net, I would use the put command. Okay. There's also commands that are going to look very similar to Linux commands that we've already learned. Things like ls or cd. Okay, those commands have the exact same meaning that they do in Linux. And so, for instance, I can do an ls on this directory, and it comes up and shows me all the different files that are out there on my fasano.net webpage. Okay, so there's FTP in a nutshell. If you need to use FTP, always look at the help. A lot of these commands are pretty self-explanatory. You can get more information on the web if you need to use something in particular. There's also graphical versions of FTP that are out there. So like a box would come up and you would just drag files from one box to the other once you've logged on to some system, that sort of thing. Another useful utility that's out there for testing internet connectivity is the ping utility. Now, ping uses the ICMP protocol that we just talked about, and what it does is it tests the connectivity between two computers. So I could do something like type ping cs.dartmouth.edu. Okay, so if I type this and hit enter, then what's happening now is that my computer is sending a small bit of information to the cs.dartmouth.edu computer, and then that computer is going to reply back and saying, yes, it's connected. Okay, and you can see here the responses. All right, so it's telling you the IP address that it's using, and then it's also telling you how much time it's taking in milliseconds to do that round trip. Okay, so I'm going to hit Control C here to stop this, and now what's going to do is it's going to give me a little summary. 5 packets transmitted, 5 received, no packet loss, and there's the total time. Then there's a little statistical thing here, the round trip time, the minimum, the average, the maximum, and then the deviation. Okay, so you can see it's taking about 135 milliseconds for my little packet to travel from me in Washington State all the way across the country to Dartmouth, and then back to me here. Okay, so that's one use of ping. You can also use ping on like your local network. For instance, my router that's on my DSL line here, the address of that is 192.168.1.1. Okay, so I can hit there, I can do ping, and you can see here that it's coming up, it's a lot faster. Okay, now the round trip average time is like 0.2 milliseconds, and that's only because it has to travel over this 3-foot wire that's connected from my computer out to the router and back. Okay, so it makes sense that it would be a lot faster. But again, this is a useful way to diagnose that my router is up and running in case it was in a different room or something, and I had a large corporate network or something. I want to make sure if I'm not getting on the network, then one of the first things I want to test is whether I'm properly connected to my router. If I am, then I can sort of do the next step. Maybe ping something that's local to me, like a name server or something like that, and then work my way out to see where the faulty connection lies. Another useful network application is the DIG utility. DIG stands for the Domain Information Groper. Okay, so this groper here will go out and sort of get information about various domains. I will get information like what the IP address is for a particular domain name, or what the name servers are that hold this domain name information, that sort of thing. Okay, so for instance, if I do a dig on www.fasano.net, okay, we're going to get a response back. Let me just scroll up here so you can see all of the output. So it's saying here, it got an answer. There was one query, it got one answer, and there were 2 authorities over it. Okay, so what it was looking for when I just say dig www.fasano.net, then what it's looking for is it's looking for the actual IP address of this domain name. And so it says it got an answer, so that means that the answer is in this list. Okay, so the question was Fasano.net, and the A here stands for the address. The answer is here's www.fasano.net, and the address is this particular address right here. Okay, so that is the IP address for this particular web server. Great. The authority section says what name servers are responsible for supplying that address. And here's the 2 name servers that have authority, okay, that they have, if this ever changes, they will change on these name servers, and these name servers have the authority over www.fasano.net. Okay, and that's what the NS stands for in this column, saying that these are the authoritative name servers for this particular query. All right. So, just a little aside, like what happens when you go to, you type in www.fasano.net into a web browser, for instance, it's not like your local name server has the information of what www.fasano.net, corresponds to in terms of an IP address, right? Your local name server doesn't have that information. So what happens, there's this whole like chain of things that happen. There's a few, like 13 authoritative name servers all around the world. Okay, those 13 large name servers called a.rootservers.net, b.rootservers.net, and so on, those things have all this grand information in them. And what they don't have, they know, sort of who to refer to get the information. So your chain of command to resolve a DNS address, like when you type it in a web browser, might be to go to one of these root servers, and then those root servers pass you on to somebody else, those things pass you on to somebody else. Eventually you will get passed on to DNS5 or DNS6.easy.com. Then those name servers there will provide the authority. They will give the actual IP address for this particular host. And then, then once you have the IP address, once the name is resolved, is what we say, then you can go ahead and, see the data that's on www.fasano.net. Well, the last thing I want to do in this nugget is I want to look at some of the important network configuration files that are out there and tell you what they're used for. So there's the etc hosts file, and this is the file that is used to do name resolution. So if there's certain addresses that you're regularly accessing, in the etc hosts file, you can correlate those names, those host names, to IP addresses. Okay, so the typical etc host file has something like 127.0.0.1, and it says over here like local host. Okay, and that's just your local IP address information. All right, but you can also put in something else in there, like if there's some particular server that you always access from your machine, well, you can write the IP address and resolve the name over here. Now remember that if you do that in etc hosts, that if the IP address of this machine should ever change, then you need to change it in etc hosts, because your machine will always look in etc hosts first before it goes out to the domain name server. All right, then there's etc services. etc services has to deal with the port mappings to various services. I showed you a web page that was out there that had all the various information about, FTP is on port 21 and HTTP is on port 80 and so on. Well, all of that stuff gets defined in etc services. And then there's etc resolve.conf. Resolve.conf contains the IP addresses of name servers that you're supposed to use to do domain name resolution. All right. If you're using like a DHCP service, like like a DSL line or something like that with DHCP, probably your name servers are also supplied to you as well. So this file would be empty. But if you have a static IP line, you have a static IP address, then you probably also have static name servers that you're supposed to use, and so they would go into resolve.conf. All right, so those are some important network configuration files. Now let's look at a couple other commands that we didn't get a chance to look at in this nugget. One of them is the traceroute command. I can't get this to work on my machine right now because I just found out there's a bug in the firmware of my router that doesn't allow traceroute to work behind it. And so I didn't want to mess with the firmware of my router, so I just skipped that part. You can look around on the internet for traceroute explanations, and you can actually run traceroute from certain web pages, and it'll show you the output. Basically, what happens is if you run traceroute from your machine to like www.google.com or something, it will show you all the intermediate points that it sort of goes through, all the hops that it goes through to get to Google. And sometimes that's good for debugging information or troubleshooting information on your system. And then there's the if config utility. This utility can be used to look at and alter the configuration settings of a network interface. So if you just say ifconfig straight up, then it'll give you one output for ETH0 or ETH1 or whatever network interface name you have. It'll tell you various things about the interface, like what its IP address is, what the net mask is for that particular machine, and so on. Then there's the netstat command. This command displays network connections. Okay, it'll display network connections, routing tables, things like that. And then there's the PPPD command. So one thing that we've sort of overlooked in this whole discussion of networking is that we're just assuming people are connecting to the network via their Ethernet card, okay, through a DSL line or a static, like a cable modem or something like that. Whereas PPPD is what you use if you're connecting through a modem, all right, like the old-fashioned way to connect to the internet. And certainly there are still people doing this. Look up the PPPD command if that's what you're doing, if you're connecting through a modem. You can also look for information on how to set it up so that you can automatically dial your ISP, how you can supply the username and the password automatically via some script. And it's all very, very simple scripting language. You would just say like password equals this, and login name equals this, and the telephone number equals this, and so on. Okay, so it's a very simple mechanism to allow you to connect via a modem. All right, well, it's time to wrap up our nugget on network fundamentals. We started with a very fundamental concept, and that is the idea of an IP address. This was the numbers that various computers on the internet are assigned, and this is what allows computers to talk to each other over the internet, the fact that each one has its own specific number. Then we talked about network classes, the Class A, Class B, and Class C networks. We talked about subnets. Remember that you can break your network down into these subnets, and the reason you want to do that is either for security reasons or to minimize the amount of Ethernet traffic that goes out over the main internet. Then we talked about net masks, and I walked you through some examples on how to calculate net masks for a couple different scenarios. And remember that the masks allow a router to determine which packets that are flying by it's supposed to take and sort of pass on, which ones it's responsible for. Then we moved on and talked about network protocols. We talked about TCP, IP, UDP, and so on. And we talked about what each of these protocols was good for. Then we moved out to the Linux screen and we started talking about networking commands and the applications that are available to you. Things like the FTP application or the ping command, things like that. And these are useful for accomplishing some task like FTP to upload or download files, or to do some troubleshooting on your network like ping or traceroute or something like that. Well, I hope you found this nugget informative, and thanks for watching.